Good morning, everyone. We're going to start today's session. Today's session, we're going to start with a new topic, which is DXC. DXC stands for Direct Extractor Connection. DXC stands for Direct Extractor Connection. So first let me explain you theoretically what is DXC, and then we do practically on this. So in order to understand DXC, we need to have basic fundamentals of BW, Business Warehouse. So there are two types of systems. One is OLTP, Online Transaction Processing System, and the other system is OLAP system, Online Analytical Processing. These systems are optimized for writes of data. These systems are in normalized format. These systems are optimized for reads of data. The data is in the denormalized format. An example for an OLTP system is an ECC system. Example for OLAP is BW, Business Warehouse. In ECC, we have tables. We write data into the tables using T-code. Or you can upload data into these tables using BDCs, LSMW. All the legacy data, you can move data to these tables, or you can write data directly using transaction code. From these tables, we associate tables to a data source. A data source is an object. A data source, it's a source of data. A data source is an object that moves container as well as content. That moves the container and the content from ECC to BW. The communication between ECC and BW is an RFC connection. It is an RFC. RFC stands for Remote Function Call. So BW directly cannot understand tables. BW cannot understand tables directly from ECC. So these tables are associated to data sources, and data sources are the objects that are used to move data from ECC to BW using an RFC connection. Like how ECC and SLT communicate via RFC, ECC and BW communicate via RFC here. So there are two important points I want to highlight over here. The first point is These data sources are also known as extractor. This you see direct extractor. The extractor here is nothing but the data source. Connection is to connect source system and target system. So in this connection, what is the target system we have? The target system is HANA. And source system is ECC. The connection between ECC and HANA, like how you have ECC to BW is an RFC connection, ECC to HANA is an HTTP connection. ECC to HANA is a HTTP connection. So the data is transferred from ECC to HANA via HTTP. Nothing but it is transferred via web. This HTTP protocol, the HTTP protocol in HANA is managed by a lightweight web application server inside HANA, which is known as Access Engine. Inside HANA, there is a lightweight web application server, which is known as Access Engine. This Access Engine, using the HTTP protocol, communicates to ECC to transfer data from data source to HANA. So what does DXE mean? DXE means directly connecting to an extractor on the ECC system. Basically communicate to the ECC system directly. The extractor which is sending data to BW, whatever the extractor that is sending data to BW, we use the same extractor to connect to HANA. Direct extractor, nothing but data source, and connection to the source system. Okay, so for example, if I create a custom table, I created a custom table. The custom table has few columns and data inside this table. So this table is created in a transaction code S11. We associate these tables to a data source, We associate these tables to the data source and the T code RSO2. So RSO2 is a transaction code where you can associate tables to the data source. And these data sources, the data sources that you have on the ECC, are replicated to BW using the T code RSDS. So technically, I'm just telling the T codes how we can perform DXE. S11 to create a table, or you can use standard tables. We can use standard tables or Z tables. Tables are associated to data sources RSO2. From RSO2, these data sources are replicated to BW using RSDS. So once this data source is available in target system, data source is nothing but the structure. It's only a structure. It's also known as extract structure. It's also known as extract, means it extracts data from source to target. That's why it is known as extract structure. So once this data source is available in BW, we activate this data source. We activate this data source. Once we activate this data source, this data source creates PSA, persistent staging area. This data source creates PSA. PSA is nothing but it's an area where all the BW data is stored in the raw format. PSA is nothing but it is how data is represented in the source system. It's the initial layer where data is stored in BW. It is known as PSA, persistent staging area. Now once we have data inside data source, once the PSA is generated, data is in the table. Now a PSA table is generated in BW after activating the data source. PSA table is generated. So PSA table is specific to a data source. So once this table is generated, in order to get data into this table, we need to execute a job. We need to execute a job in BW. This job is known as info package. So info package is a job that is used to transfer data from ECC using RFC connection to PSA. So when you execute this job, so this is the job that initiates the data transfer. It initiates the data transfer from ECC table. So a copy of data is on the ECC. The next you can see the copy of data in PSA. So on the source system, data is maintained on the ECC on the table, and target BW maintains data in PSA. So PSA full form is persistent staging area. Now inside BW, if you little zoom into this, little zoom on the BW system, if this is the BW system, so this is the flow inside the BW. So whatever the things I'm drawing inside this system is nothing but I'm trying to zoom this BW. So what is the initial object? Data source. Inside data source, what do we have? PSA, persistent staging area. From PSA, you can do something called transformation. Transformation. So transformation is nothing but to connect source and target. You can connect source and target. So transformation is an object that connects the source object with the target object. For example, how do you connect two mountains is via bridge. You can connect two mountains via bridge. So here, this is source and this is target. How do you connect here? So in this way, a transformation is nothing but it maps the columns of the source to the objects of the target. So that whatever the data that you have over here, it is basically transferred to that column. So this mapping of columns is done in transformation. So transformation is an object that is used to connect source and target within BW. So this is happening within BW. The source object is PSA. What is the target object? The target object is DSO, data store object. These objects are optimized. These objects are optimized to report data in a line item fashion. in a line item fashion. So line item in the sense detail level. The level of the data in which you can report is highly granular. The granularity of data is very, very detailed. For example, the difference between a VBAK and VBAP. VBAP has data in a detail level. VBAK has data in a summary level. DSOs are suitable to store data similar to VBAP table. So these objects are suitable for line item reporting. On top of DSO, data store object, you have another object called InfoCube. InfoCube is similar to an analytic view in HANA. It's similar to an analytic view. InfoCubes are optimized. InfoCubes are optimized to process aggregated data. They're optimized to process mass aggregation of data. They're optimized to process mass aggregation of data. Okay, so here within BW, if you notice, there are primarily three important objects. One is PSA. It's the initial layer where data is stored. DSO, data store object, that is used to store data in line item fashion. InfoCube. InfoCube is an object that stores data in a summary level. So summary level, line item, and raw data. And transformation is an object that is used to connect the source with the target. So for every source and target, for every source object and the target object, you need to have a transformation between. So what are we trying to do here is we are only creating a flow of data. We are creating a flow. So if you have data on the ECC, how the data from ECC is transferred to PSA via RFC connection. From here, the further distribution of data, I'm going to distribute to an object called DSO. And from here again I'm going to distribute to another object called InfoCube. The distribution of data within BW is done using DTP, using data transfer process. So DTP is an object that is used to transfer data within BW. So DTP is a job that initiates the data transfer within BW. Okay, so let us see what are the things we are learning here. First one is data source. The second object is PSA. Third object is DSO. Fourth object is transformation. Fifth object is InfoCube. Sixth object is info package. Seventh object is DTP. So what is data source? Data source is an object that is used to transfer data from ECC to BW. PSA, persistent staging area. This is the inbound layer of data source. PSA is inside the data source. So this is the first layer to store data in BW. But how does PSA get data? using info package. Info package is an object that initiates the data transfer from ECC to BW. DSO, data store object. It is used to store data in line item. Transformation is an object that is used to connect source and target. Info cube is a multi-dimensional object. It's similar to an analytic view. This object is optimized to store aggregated data, just like VBAK. It doesn't require details. You can store data in aggregate format. Info package transfers data from outside the BW to inside the BW. DTP transfers the data within BW. So this is the flow. How a flow of data can occur. And once you have this data in these containers, once we have data in these containers, these containers you can do reporting. You can generate reporting on these objects. Means you can report data. Whatever you are storing here, to read data from these objects is nothing but reporting. A data source is a place to store data. Inside the data source you have PSA. It is just an empty table. Just like you have a container, an empty container. Empty container is a data source. Excuse me. Empty container is the data source. Inside the data source you have PSA. The PSA has data. So who is actually holding the data? The data is basically inside the PSA. Now how do we get data into PSA? By using job. Unless and until you switch on the job, the data doesn't come over here. So what is the technical name for job? Info package. Info package means packets of information. You see, packets of information. Info cube. A cube is a multi-dimensional object. Transformation. Transform data. And data store object. An object that stores data in a line item fashion. Persistent staging area. An area to stage data persistently. Data source of data. Data transfer process, the process to transfer data from source to target. And this is within BW. So within BW we use DTP. Outside the BW to inside the BW we use info package. Okay, so now we know the flow of data. So once again, ECC, table, and data source. This is BW, data source, transformation, DSO, transformation, info cube. On top of this, you do reporting. Source system, ECC, BW, table, data source, RFC, remote function call, data source, transformation, DSO, transformation, info cube. So where is data here? Data is over here. How is data transferred? Using data source. What is the communication method? RFC. How data comes from here to BW? Info package. From here to DSO? DTP. From DSO to info cube? DTP. So DTP, one DTP to transfer from here to here, another DTP to transfer from here to here, info package to transfer from here to here, and data source is associated to table. So data source is just like a view. Now let us discuss about more details into BW system. So to understand DXE, you need to have fundamentals of BW. For example, I have a table with 4 columns. Customer, what materials, what is the amount, and what is the quantity. A simple table with 4 columns. So this is the table. The same table data I can store in DSO. The same table data I can store in InfoCube. So data source can store the same kind of data. DSO can store same kind of data. InfoCube can store same kind of data. So these different objects can store same kind of data. But what is the difference here is the difference between a data source, data store object, and InfoCube is this is aggregated, optimized for aggregation. This is optimized for line item reporting. And this is optimized to store data. So the question here is, whatever the table we have on the source system, when you transfer, now this is one table, this is another table, this is a third table. When you transfer data from this table to this table, we cannot directly transfer. We need, what is that we need? We need a transformation between. In order to map, I need to map, okay, this column data to this column to this column. I need to do the mapping. Only once I do mapping, I can transfer from here to here. And this mapping is known as the mapping of data is known as the transformation. The mapping of data is known as transformation. Unless and until you don't map, we cannot transfer. So this is known as you know, usually they call this as table. Table consists of rows and columns. The first row is a header. Table consists of rows and columns. The same table which is storing data in a column. This column in BW, we have to create something called info object. So what is info object? Info object is an object that stores information. Info object is an object that stores information. So the customer has 1, 2, these are the data that this column has. This is known as a column inside a table, but in BW this is known as info object. So instead of calling a column, we call this column as info object. So here, how many columns I have in a table? I have 4 columns. So is it appropriate to tell how many columns I have in this table? No. How many info objects are there in this table? 4 info objects. I have 4 columns inside this table. I have 4 info objects inside this table. So columns are nothing but info objects. It is a basic building block. Info object is a basic building block to create a solution in BW. Like how bricks are important to create a wall. How bricks are important to create a wall. Info objects are important to create a data warehouse solution. To create a data warehouse solution, we require info objects. Info objects are basic building blocks that can store data. So these info objects, like you know, in HANA we have master data. Master data is divided into how many types? 2 types. Sorry, 3. I'm sorry. One is attributes, text, hierarchy. The same master data is handled in info objects, but info objects of type characteristics. Info objects of type characteristics. In HANA you have transaction data. Transaction data can be handled by transaction data using amount and quantity related data. So info objects of type key figure. Info objects of type key figure handle transaction data. So these key figures in HANA are known as measures. These characteristics in HANA are known as attributes. Characteristics are known as attributes and key figures are known as measures. So if I have 4 columns over here, if you have 4 columns in a table, these 4 columns, how many are info object of type characteristics? You see I have 4 columns: customer, material, amount and quantity. So we have 2 objects of type char and 2 objects of type key figure, because amount and quantity are key figures, the customer and material are characteristics. So one more important point here is, along with this terminology, now you have a new object which is 8, which is info objects. Info objects are divided into 2 types. One is char, which can handle master data, and the other one is key figure, which can handle transaction data. So both characteristics and key figures are handled inside the info object. These are the basic building blocks. These are just like bricks to the wall. Info objects are bricks to the data warehousing solution. So if you have 4 columns in a table, the tables that stores master data are known as characteristics. The table that stores transaction data is nothing but info object of type key figures. So this terminology will be useful when you work with the integration of HANA with BW. And if in your project you have BW, when you're working on this integration aspect, you come across this terminology. So what is the object that stores master data in HANA? Attributes. What is the object that stores master data in BW? Characteristics. What is the object that stores measures in HANA? What is the object that stores transaction data in HANA? It's measures. Transaction data in HANA is handled by measures. What is the object? What is the object that takes care of measures in BW? Key figures. So until here, if you have any questions, just please let me know before we proceed to the next level. So just to summarize the entire aspect, I'll just try to summarize here. BW is a data warehousing solution. In BW, you have, just write the hierarchy here. First is the info area. Under info area, you have catalogs, catalog. Like how you have in HANA schema, how you have package, how you have content. So in BW, you have the first, on the top you have info area. Under info areas, you have catalogs. Under a catalog, you can create info objects. You can store info objects. Under info objects, there are two types. One is char, characteristics, and the other one is key figure. Key figure store transaction data. Characteristics store master data. Based on these info objects, I can create a data flow. Based on these info objects, I can create a data flow. Data source, transformation, DSO, transformation, info cube. So these info objects are the basic building blocks that create a DSO. These info objects are the basic building blocks that creates info cube. So using these objects, I'm going to create a wall called DSO by using multiple info objects. You see here I have multiple info objects. You have a table. In this table you have multiple, so you have 4 info objects. 2 are chars, the other 2 are measures. So using these info objects, I'm going to build DSO, build info cube. I get data into data source from ECC. ECC has table. From table to data source. From table to data source. From data source to data source in BW. This is the source system, and this is the target system. We use RFC to transfer data from this object to this object. How? Info package. How data comes here? DTP. How data comes here? DTP. Finally, what we're going to do on this objects, I'm going to do reporting, read data. I'm going to read data from these objects, do reporting. Who is going to generate? Business users. Business users are going to generate these reports. So info area is just like a package in HANA. Catalog is like a sub-package. Info objects of type characteristics are like attributes. Info objects of type key figures are like measures. Info cube is like an analytic view. DSO is also like an analytic view. Info objects are like attribute views. These are like measures. So info area is equal to package. Catalog is equal to subpackage. Info objects of type char are like attributes. Info objects of like key figures are like measures. Info cubes are similar to analytic views. DSOs are similar to analytic view. So this is the mapping of objects from BW, mapping of objects from BW to HANA. DSO stands for data store object. Data store object. Write down here. You see all these objects are this is nothing but this is known as data flow. And these are nothing but the technical objects I'm done mapping to HANA. So tomorrow what we will do is we'll start to create this entire data flow. How from ECC data is transferred to BW. And then how DXE, so step number 1 is to see the flow of data from ECC to BW. And step number 2 is how in a sidecar scenario, what is the advantage of implementing a DXE to move data to HANA. And third one we see BW powered by HANA. BW powered by HANA. So step number 1, when BW is on MS SQL. Step number 2, in a sidecar scenario using DXE, how to move data to HANA. Step number 3, what is the new solution in BW powered by HANA? Tomorrow when we see practically on the system, we can correlate whatever I'm doing today. We can see practically on the system in tomorrow's session. Anyone have any questions? Please type in your questions. I can read out your questions and answer your questions. So here we have one question here. We have extractors from ECC to BW. Then is the info package are same as extractors? Okay. I'll just tell a very simple example. For example, we have a bottle of water. So in the bottle of water, what is extractor? Or what is info package and what is data? So in the bottle of water, what is extractor, what is info package and what is data? Extractor is nothing but the container, nothing but the bottle. The data inside the extractor is nothing but the water. So extractor is nothing but the container which holds the content. Bottle holds water as a content. Extractor holds data as its content. But how a bottle of water can get water into the bottle? So basically we will use funnel or anything. You can use funnel or you can just get a glass and then pour water into the bottle. So the process of getting the data or getting the water into the bottle, that is one process. The process of getting water into the bottle or getting the data into an extractor. Data is nothing but the processed information. So getting the information into the extractor is done by info package. So these are nothing but packets of information you're pouring into the extractor. So how you get data into an extractor is taken care by info package. But once you get the data or the information into the extractor, where does it store? It stores in PSA. The logical name is the data source, but the inbound layer of data source is nothing but the PSA. This is similar to something like this. For example, this is similar to, you have a coconut. Inside the coconut you have the outer shell. We just call it as coconut, but the actual water is inside. So the inside shell is known as the PSA. Inside of the coconut is where the actual data is stored. That is known as the PSA. The outside is known as the extractor. So extractor is inbound layer of data source. So extractor and data source both are same. There is no difference. Extractor and data source, both the terminology is same. So inside the data source, to hold the data, an extractor cannot hold. To hold data, we need a PSA. Here we have one question here. What will be the exam fee for associate level exam based on SPS 10? You can, participants who want to write the exam, you can just fix one date. I make sure that everyone clears the exam. I can make sure that you all clear the exam. The latest code for exam is C_HANA IMP 151. C_HANA IMP 151. Participants who are outside India, you can book the exam, no problem. I can take care on how you can clear the exam. Okay, you can be confident about that. 100% I can make sure you can clear the exam. For C_HANA, the exam code is you can fix one date, C_HANA IMP 151. So next we have one more question here. Can we use BODS or SLT for transferring data from BW to HANA? Can we use BODS and SLT for transferring data from BW to HANA? BW to HANA. Yes, you can do using SLT and BODS also. But only you can transfer data from BW to HANA using tables. You can use BW tables, use SLT to transfer to HANA. Is it possible, right? If it is possible, then right is the importance of DXE. The importance of DXE is, in a sidecar scenario, whatever the data that is going to BW, I bypass the flow and get data to DXE. I bypass the flow and via DXE I get data to HANA. So DXE enables us to bypass the existing data flow. Same data flow I can get to HANA. So whatever the reports that we're generating on BW, now I can generate in HANA itself. So I am in Saudi. Where can I register for exam? You can contact the local SAP. You can contact SAP Education, Saudi SAP Education. I know Saudi is very big, but where in Saudi are you? So you need to check, like you have Al Khobar, you have Riyadh, you have Jeddah. So you need to contact the local SAP office, SAP Saudi Arabia. So next question. Similar to a calculation view in HANA, is there something similar in BW? Yes, you have composite provider. Composite provider is similar to calculation view. Please take at least, so today's date is 28. Please book a date after April, after 20 days. If anyone want to book, please book date after 20 days. 20 to 25 days, you can book the date, approximately. Just you can keep one date in mind, because we can discuss HANA SPS 10. The latest certification, I can help you to clear that certification. Next question. If we bypass the flow, what it will create in HANA? It creates a column table. So if you bypass the flow to BW, it creates a column table in HANA. The exam fees, you need to contact SAP. You have to contact SAP for the exam fee, because SAP decides the exam fee based on country to country. But usually it costs around 550 euros. So please call SAP and you have to talk to them. So I will discuss all the questions for you. I will discuss all the questions that can help to clear the exam. As and when necessary, we will take few days, 1 week, completely to discuss the certification question. So after we discuss the question from certification, once you get familiar about the subject, then you can, after 20-25 days, you can book the exam. The certification exam is based on SPS 10. Certification exam is based on SPS 10. Thank you, everyone. We'll see you in tomorrow's session. Have a good night and good morning to everyone. I'll see you tomorrow, same time. Thank you.